In this video, I am going to discuss about the addressing modes of 8051 microcontroller. Before that, we'll have a look at the basic block diagram of 8051 microcontroller. So it consists of a CPU, a RAM is a read and write memory and is used for temporary storage of the data. ROM, which is a read-only memory and it is used for the permanent storage of the data, and the code is written into this memory. IO ports, timers, serial ports, and all these peripherals are embedded on a single silicon chip. And whenever you want to use the microcontroller for the development of a control unit, you need to write the instructions in the assembler or compiler, and the resultant hex code need to be loaded into the ROM memory. And whenever the CPU is ready for the execution of the instructions, it fetches the instructions from the ROM memory, and during the execution of the instructions it takes the data, that is it reads the data from the RAM and ROM memories and writes the data only to the RAM memory. The CPU can access the data in various ways while executing the instructions, because the data could be in a register or in a memory location or be provided as an immediate value in the instruction. These various ways of accessing the data by the CPU are called addressing modes, and the microcontroller supports various modes, and these modes are predetermined when they are designed, and later on they cannot be changed. 8051 microcontroller supports 5 addressing modes. They are immediate addressing mode, register addressing mode, direct addressing mode, register indirect addressing mode, and indexed addressing mode. Here we are going to discuss all these modes with examples. Before that, we'll have a look at the 8051 assembly language syntax. It consists of 4 fields. Here you can see these are the 4 fields and these are the instructions. And if you see the last instruction, move a comma hash 25h, the 25 value is directly moved to the A register value. Here A is the destination and 25 is the source. First mode is the immediate addressing mode. In this mode, the source operand is a constant and it is preceded by hash sign. By using this mode, information can be loaded into any of the 8051 microcontroller registers, including the data pointer register. And the example instructions for this mode are, so move a comma hash 25h, the 25 hexa value is moved to the A register, and 62 decimal value is moved to the R4 register. And if you see this instruction, the 4521 hexa value is moved to the 16-bit data pointer register. And the other mode is the register addressing mode. This mode uses registers to hold the data to be manipulated. If you see immediate addressing mode, the data is directly present in the instruction, whereas in register addressing mode, the data is present in the register. And the examples for this mode are, so move a comma R0, so the R0 value is moved to the A register. And similarly, if you see this instruction, the A register value is moved to the R2 register. And if you see this instruction, the contents of A and R7 are added and the result is put into A register. The other mode is the direct addressing mode. Here the memory location address is used in the instruction. Here if you see, move a comma 25h, 25h is the address of the memory location where the data is present, and this instruction copies that data to the A register. And if you see this instruction, so the A register value is moved to the memory location 56h. And if you see move 90h comma A instruction, the A register value is moved to the 90 memory location, and 90 is the address of the port 1 special function register. And the other mode is register indirect addressing mode. If you see in direct addressing mode, so the address of the memory location is used in the instruction, whereas in this mode the address is loaded in the register and the register is used as a pointer to the data. And for this mode, only R0 and R1 registers are used for pointing the data, and before the register at symbol need to be placed. If you see this instruction, move a comma at R0, R0 is having the value that is the address, and the data that is present in that address is copied to the A register. And if you see this instruction, the B register value is moved to the address that is pointed out by R1 register. And this concept can be understood by seeing this numerical example. Suppose if R0 and R1 registers are holding 10h and 11h, these are the addresses, And this instruction, what it will do, so the data that is present in 10H, that is 02 value, is moved to the A register, and this instruction copies the B register data. Suppose if B is having 03H, so that data is copied to the address location 11H. And if you see, the 8051 microcontroller RAM is divided into two parts, that is a total 256 bytes are present, and first part is having 128 bytes ranging from 00 to 7FH, and this party can be addressed by both direct and indirect addressing modes. And the other part is 80 to FFH, this is also 128 bytes, and this is accessed by only direct addressing mode. Advantages of register indirect addressing mode is that data can be accessed in a dynamic way rather than static as in case of direct addressing mode. And the disadvantages for this mode is only R0 and R1 registers are used, and these are 8-bit wide. Only the internal RAM can be accessed by using this mode, because if you want to access external RAM or on-chip ROM, so more than 256 bytes need to be present. So for this purpose, 16-bit pointer need to be used. The other and last mode is the indexed addressing mode. So the address of the memory is indexed, that is added to form the actual address of the memory. So this can be understood by seeing this instruction. Here the content of the A register is added to the content of the DPTR register, and the resultant value is the memory location address from where the data is moved to the A register. And the instruction MOVC is used for accessing the on-chip ROM memory locations. And these are the instructions. So that by seeing these instructions you can understand the index addressing mode. So DPTR is loaded with 400H and A is loaded with 1, and 401 address data is moved to the A register. Suppose if 401 address is having a data 02, that data is moved to the A register. This addressing mode is commonly used for accessing the lookup tables. So what is lookup table? Lookup table is a widely used concept in embedded programming that allows access to data stored in table with minimum operations. So this can be understood from this program. Here we need to write a program to get the value from port 1, and then we need to calculate the square of that value and send to port 2 continuously. We know the square of different numbers, so that numbers are stored in a lookup table starting from 300H. So this is the program for calculating the square of the number. So here we are making port 1 as an input port, and this is the loop. So the port 1 value is continuously monitored, and correspondingly the square number is calculated from the lookup table, and it is put to port 2. The instructions used for accessing the external data memory space. Suppose if your application requires extra RAM and ROM, for that memory to access, we need to use MOVX instruction as shown here. Thank you for watching my video.